What if the biggest discovery in human history is less than a year away? Not something built on Earth, not something made by human hands, but proof that life may exist beyond our planet. Right now, scattered across the galaxy, there are worlds orbiting distant stars, worlds with oceans, atmospheres, clouds, and complex chemistry. Worlds that don't exist in science fiction, but in real astronomical data. Some may host weather cycles, storms, and chemical reactions that hint at life. Some may even harbor conditions similar to Earth's primordial oceans, where life first began. And for the first time in human history, we have telescopes, instruments, and computational tools powerful enough to detect signs of life across light years. Scientists say 2026 could be the year everything changes. The year we detect alien fingerprints in the atmosphere of an exoplanet. The year a distant world quietly reveals that life is not unique to Earth. The year humanity finally confronts the possibility that we share this universe. Welcome to Galasky, where we explore the mysteries beyond Earth, not just as science, but as meaning. Today, we ask one of the most important questions ever posed. Will 2026 finally reveal evidence of alien life on exoplanets? For most of human history, planets were rare. We believed stars were distant suns shining alone in the darkness. Then, in the 1990s, everything changed. Astronomers confirmed the first planet orbiting another star, an exoplanet, and almost overnight, the universe became crowded. Today, we've confirmed over 5,000 exoplanets, with thousands more awaiting verification. From worlds larger than Jupiter to rocky planets barely bigger than Earth, the diversity is staggering. Some orbit red dwarf stars, some race around their suns in just days. Some sit in calm, stable orbits where liquid water could exist for billions of years. Statistically, this means something astonishing. Planets are not rare. Earth-like planets are not rare. But discovering habitability is far more complex. It's not just about size or orbit. It's about chemistry, atmosphere, radiation, magnetic fields, and orbital stability over billions of years. Some planets are tidally locked, always showing the same face to their star. Some may have oceans entirely covered by ice. Some may have atmospheres heavy in greenhouse gases, creating extreme climates. The possibilities are staggering, and each one tells a different story about the potential for life. The question is no longer if habitable worlds exist, but whether life actually took hold on them. And 2026 may be the first year we finally get a glimpse of that answer. So why does 2026 matter so much? Because science moves in waves, and 2026 is where several waves collide. By then, astronomers will have years of refined data from the James Webb Space Telescope. Not first impressions, but deep, repeat observations. Not guesses, but comparisons across time. At the same moment, new modeling techniques will allow scientists to separate biological signals from geological noise with unprecedented confidence. Artificial intelligence will scan patterns humans could never see. Global observatories will coordinate follow-up observations. False positives will be challenged, tested, and stressed. This is the transition from discovery to confirmation. 2026 isn't about hype. It's about the moment when evidence becomes strong enough to demand attention. Unlike past searches, scientists will examine seasonal changes, planetary weather patterns, and atmospheric cycles to ensure nothing is misinterpreted. Every observation will be checked, rechecked, and compared. Even tiny variations in light intensity or a small spike of methane could hint at something far bigger than we've ever imagined. Let's be clear about what scientists are actually looking for. They're not searching for intelligent beings. They're not searching for spacecraft or cities. They're searching for chemistry that shouldn't exist without life. On Earth, life constantly alters the planet's atmosphere. Plants release oxygen, microbes produce methane, oceans regulate carbon dioxide. These processes keep Earth in a delicate imbalance. Without life, Earth would look very different. So when an exoplanet passes in front of its star, astronomers analyze the starlight filtering through its atmosphere. Each molecule leaves a signature, like a barcode. Individually, these gases don't mean much, but together, in the right proportions, they can reveal something extraordinary. A planet that shouldn't be alive, but appears to be. To detect these signs, telescopes measure the tiniest changes in light intensity across different wavelengths. They track absorption lines of oxygen, methane, water vapor, carbon dioxide, and other molecules. They also watch how these signals vary as the planet rotates or as it moves closer or farther from its star. Life is dynamic, and its fingerprints are dynamic too. And in 2026, we may finally detect patterns that repeat, pointing toward life in a way we've never been able to before. The James Webb Space Telescope changed the rules of astronomy. Unlike previous telescopes, Webb was designed to see in infrared, perfect for detecting heat, chemistry, and distant planetary atmospheres. By 2026, Webb will have observed dozens of rocky exoplanets in habitable zones, tracking changes across time instead of relying on single snapshots. This matters because life is dynamic. Atmospheres shift, clouds move, chemistry responds to seasons. Seeing those changes is critical. Already, Webb has detected water vapor, carbon compounds, and complex molecules on distant worlds. Not proof of life, but proof that these planets are chemically active. With each observation, scientists refine their models. They simulate planetary climates, test for false positives, and compare multiple worlds. By 2026, all this data may converge, pointing clearly toward a planet that may harbor life. Some of the most exciting possibilities include detecting atmospheric breathing, seasonal or cyclical changes in gases that indicate lifelike processes. These patterns could take years to confirm, but 2026 will be a pivotal year for first glimpses. Out of thousands of known exoplanets, only a handful stand out as truly promising. These are worlds with stable orbits, reasonable temperatures, and atmospheres thick enough to protect surface chemistry. Planets like TRAPPIST-1e, locked in a compact system of rocky worlds. Planets like K2-18b, showing intriguing chemical signals. Planets like Proxima Centauri b, orbiting the nearest star beyond our Sun. These worlds are not distant abstractions. They are becoming places with measurable skies, temperatures, and compositions. By 2026, scientists will compare multiple candidates, eliminating coincidences and strengthening real patterns. They'll watch how these atmospheres evolve over time, looking for cycles that are only explainable by life. This level of analysis was impossible even 5 years ago. And even beyond Earth-like planets, some super-Earths may hold subsurface oceans, tidal heating, or unusual chemistry that could surprise us. Life could exist in ways we have barely imagined. Evidence doesn't arrive dramatically. It arrives carefully. Scientists will not claim certainty. They will present probabilities, margins of error, and competing explanations. But when those explanations begin to collapse, when geological models fail to explain what biology can, that's when history changes. The phrase "consistent with biological activity"
may sound cautious, but behind it lies a seismic shift. Because once life is a valid explanation, it can never be dismissed again. In practical terms, this evidence may be subtle, perhaps a combination of oxygen and methane fluctuating seasonally, perhaps an unusual ratio of water vapor to carbon compounds. But even subtle signs, repeated consistently across observations, will be enough to convince scientists that life is likely present. And yet, there is another possibility. What if 2026 reveals silence? No biosignatures, no chemical imbalances, no convincing signs of life. At first, it would feel disappointing. After decades of searching, after billions spent on telescopes and missions, but silence would also be profoundly informative. It would suggest life is rare, maybe even extraordinary, that the conditions on Earth, the oceans, the atmosphere, the magnetic field, are far more unique than we imagined, that life is fragile and the universe may be far quieter than we hoped. But even in that quiet, humanity would gain knowledge. We would understand which planetary conditions fail to support life. We would learn how delicate the balance of habitability truly is. Future missions would focus on the most promising candidates, armed with better data and sharper models. And Earth itself would suddenly feel more precious, a tiny oasis of life in a vast, silent cosmos. Protecting it would no longer be just a moral choice, it would be a cosmic responsibility. Even in silence, the search itself would inspire awe. It would remind us how rare and remarkable our existence is, and fuel humanity's curiosity to explore further. Because the absence of life elsewhere doesn't mean the universe is empty, it means Earth is extraordinary, and the story of life here is even more worth telling. And in that reflection, we find motivation, not despair. Motivation to continue searching, to continue reaching, and to continue looking up at the stars with wonder, knowing that each observation brings us closer to understanding our place in the universe. Somewhere in the galaxy, a planet may be quietly alive, its presence revealed not by light, but by chemistry. In 2026, humanity may finally learn whether life is a cosmic accident or a universal rule. Here on Galasky, we explore these questions not just to know the universe, but to understand ourselves. If you want to witness humanity's biggest discoveries as they unfold, subscribe to Galasky, because the universe is vast, and we are only beginning to understand our place within it.